Hi guys, welcome back to YouTube channel Chemistry Live UGPG. So today we are going to talk about variation of electronegativity. So this will be highly beneficial for BSc Chemistry students under CBCS syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So this is the syllabus, a core 1 paper, unit 2, that is periodicity of elements. So let's discuss the variation of electronegativity in periodic table. So we can see fluorine 4.0, chlorine 3.0, bromine 2.9 and iodine 2.6. So this chi, this is the way how we represent electronegativity value. So chi decreases or electronegativity decreases in a group from top to bottom. So electronegativity will decrease down the group. And electronegativity increases in a period from left to right. So it will increases along the period from left to right. So if an atom has hybrid orbital with greater s character, so it would be closer to the nucleus. So the electronegativity of the atom would increase with increase in s character of its hybrid orbital. So suppose methane. So it is sp3 hybridization carbon atom. So it has 25% s character. Similarly, ethene. So it is carbon atom is sp2 hybridized. So it has 33% s character. Similarly, acetylene. Here carbon atom is sp hybridized. So it has 50% s character. So due to greater electronegativity of acetylene, so the bond pair is more pulled towards carbon. So facilitating release of H plus ion. So acetylene is acidic and methane is neutral. Similarly, we can find out the percentage of ionic character from electronegativity value. So percentage of ionic character equal to 1 minus e to the power minus 0.25 whole into chi a minus chi b whole into 100. So partial charge or ionic character in a covalent bond is due to the difference in electronegativity of atom A and B. So the greater the difference in electronegativity, the greater would be development of ionic character and higher is the bond stability. Next is a charge on atom. So an atom which acquires a positive charge, either integral or partial, so tend to attract the electrons more strongly than neutral atom. So hence a cation is more electronegative than the parent atom and as well as of anion. So hence higher the positive charge on the atom, that is the oxidation state, so greater would be the attracting power towards electron and greater would be its electronegativity. So for example HClO, so here chlorine has +1 and HClO3, so here chlorine has +5. So this will be more electronegative. So H plus release would be easier. So hence HClO3 behaves as stronger acid. Then what is group electronegativity? So the electronegativity of an atom depends upon considerably upon the nature of different atoms or substituents or groups attached to it. So carbon atom in CF3I and here it is CH3I. So this CF3I requires greater positive charge. So in CF3, the carbon atom is more electronegative or more electron pulling than CH3I. So CF3I plus OH minus ion. So you would get CF3H plus IO minus. And if you react CH3I plus OH minus, so you get CH3OH plus I minus. The next is bond order. So higher bond order tend to shorter bonds. So smaller atoms tend to have higher electronegativity. So more electronegative atoms tend to form shorter bonds. So triple bond. So here 1.2 angstrom. Double bond 1.34 angstrom. and single bond CC single bond 1.54 angstrom. So in the case of a triple bond, you have 50% S character, and double bond 33% S character, and single bond 25% S character. So higher percentage of S character makes shorter bonds, and higher bond order are the strongest bond. So we would use Shoemaker and Stevenson's equation. So DAB equal to RA plus RB minus 0.09 whole into chi A minus chi B. So these are the electronegativity of atom A and B. So DAB is the actual bond length of atom A and B. So similarly RA and RB are the covalent radii of atom A and B. Sorry, so this is should be B. So chi A minus chi B, that is the electronegativity difference. The next is Sanderson's electron density ratio. So it is otherwise called electronegativity equalization. So the electrons distribute themselves around the nucleus of an atom in the way that minimizes or equalizes their electronegativity. So whenever two or more atoms engage with different electronegativity with bond formation, so the charges become equalized within the molecule, and this is the formation of a dipole moment as a result. So electronegativity is the measure of how strongly the atoms attract electrons towards themselves. So electron loss causes an increase in electronegativity because atomic nucleus now even more strongly wants electrons and vice versa. So electron gain results in decrease in electron negativity since the atom has the electron so that it wants, and it is less ambitious to get it. So Sanderson's finding reflect this behavior of atom. So please subscribe to our channel Chemistry Live UGPG. This is also available in the website www.chemistryliveugpg.com. For class 11th and 12th, this is the channel Foundation Chemistry AV. So this is a simple step towards e-learning, making life better. Thank you all for learning.